That's the one. Okay. So, talking about AREDN, and for anybody who doesn't know what the heck AREDN is the Amateur Radio Emergency Data Network. Now, I think that's a bit of a misnomer. I think it should just be ARDN, Amateur Radio Data Network, because it works just fine even when there's not an emergency. In fact, it arguably may work better when there's not an emergency going on, right? So, but we're going to be talking, we've been doing this year, we've been doing these deep dives in our advanced class on this year. It's all been about AREDN so far. And um, there's a lot of stuff going on with AREDN right now. The Salt Lake County ARES has a big push to get an AREDN network up. They've been working with Intermountain Healthcare. They're on board with potentially putting radios on their buildings, which is pretty awesome. There's been some conversation with Utah Poison Control. They're on board with possibly putting a radio on their building. Um, there's some interesting things happening, and so we will see how that pans out. But what we're talking about today is applications on the mesh. So let's start out. We just talked about AREDN networking. So we're planning and building out a networking infrastructure. So that's the the routers, the nodes on the network that all come together to provide this network. Okay. And it's great. The AirDen software gives us a mesh network. And what the mesh network does is it lets us basically have a pretty fault tolerant network. With a mesh network, you have nodes that can talk to each other and they figure out between them the best way to get from one node to another. So traffic that enters the network from one point and needs to get to another point will find the best route to get through that mesh. And if a node goes away, the network will route around that. If a new node appears, the network will take advantage of that and utilize it, right? So it's a pretty cool technology. It leverages the OpenWRT router software that is freely available and which runs on a bunch of the standard wireless ISP commodity hardware, particularly from Ubiquiti, MikroTik, um, TP-Link, and GL-iNet are the four hardware platforms that are mainly supported. Now, it also runs on a few other things. This new OpenWRT1 box, it'll run on that. And there's a couple other things that it'll run on as well. But it's an ongoing process. There's people that are working on this on a daily basis, and things are happening with it. So it's not static. It's actually in development, and things are happening. So the reason for building this network is to support high-speed data traffic. Now, how fast can we do data on VHF? 1200 baud, right? And that's you're pushing it for 1200 baud on VHF. You can reliably get 300 baud on VHF. You can push it to 1200, but you're reliably you can get 300. On 9600, you can get on 440, you can get pretty good speeds out of that. You can get 1200, you can get probably 4800 on that without too much effort. How about on HF?
PSK 31.
Yeah, so you 31 bits per second, right? Yeah, so um, yeah, it's not speedy. And when you're shoveling a lot of data around, it can take a while, and that's okay if you've got a while, right? But some things that you want to push around are big, and big things take a lot longer. I think we did an experiment when we were first playing with WinLink, where we fired up a packet radio connection on VHF to an RMS system, and we sent an email through that had a like a 2 megabyte attachment, and it took 12 minutes to push that over the air, which I thought was great because we were actually getting some good speed out of it. And yeah, if you're starting to push around image files or audio or recordings or anything like that, it's not going to be going real fast for you.
I don't know. I started a JPEG download back in 1982.
I used to have this shirt.
Last night.
He used to have this shirt that had Dilbert, and he's sitting at the computer, and there's spider webs all over the computer and him, and he's got the mouse, and it says, estimated time to completion, and the bar is like 99.98%, and it says the estimated time to completion is like 47 years or something like that. And so, I mean, anybody who's been around in the BBS days and the dial-up modem days is familiar with this concept, right? And we are so spoiled by our high-speed internet services that we have access to nowadays. I mean, I've got a gigabit fiber at my house and I love it. It's great. I can do anything I want. I don't have to worry about bandwidth. It's amazing. I can't do that with amateur radio, right? So, well, actually, I kind of can now. AREDN operates on the 2.4 gigahertz and 5.8 gigahertz bands, which amazingly coincide with the Wi-Fi 2.4 gigahertz and 5.8 gigahertz bands. And we are a secondary user on those bands. Those bands are basically open for anybody to use. And so we can get on there with our handy dandy amateur radio license and pump out up to 1500 watts there if we really want to be mean. Now, obviously, we don't really want to be mean, so we're not going to do that. But we have a legal authority to do that if we had a need to. Um, it's much better to use less power and have more links and have things work more cleanly. But we could do that on a long haul link if we needed to. We could run quite a bit of power on it. And that's not just, pumping 1500 watts into the antenna. That's 1500 watts coming out of the antenna. And so I've seen some pretty amazing antennas built for Wi-Fi that will take a, you know, tenth of a watt signal and turn it into something amazing, right? So, but we can do that with our amateur radio licenses. So we want to build this high-speed data traffic network, and we're going to use AREDN to do it. And we're going to have different pieces of hardware spaced around the valley and other locations potentially. Then what? What do we do with it? We got this network. Now what? Well, that's what we're going to talk about tonight. We're going to talk about what we can do with it. So first, I want to get a couple of terms out of the way here, and that's when I talk about an internet, I'm talking about an internet. That's different from the internet. Okay. Now, back in the day when the internet was young, we used to distinguish it by using a capital I for the internet, right? Dan, you probably remember that. You were probably only 70 at that time, right? So, you would remember that. But we would use a lowercase I for an internet that was not the internet. And so, what is an internet? An internet is basically just a collection of interconnected networks. So, you've got multiple networks, they're connected together. That makes an internet. Okay. And we've all heard of the concept of an intranet. My company has an intranet and we do all of our stuff on it, right? Well, that's basically just an internal network for an organization or group. It could consist of multiple networks. It could be an internet, but because it's internal to their use, they call it an intranet because it's not connected to the outside or it's connected in specific controlled ways. Okay. The AREDN is an internet. When we build our network here in the valley, we can hook into another network, a supernode network, and we'll talk more about that in a second. So you'll see what that actually looks like. We can connect into another network and from there reach other networks. So it's a connection of these other networks. We're not limited to just the one network. Okay. So it is an internet, but it is not the internet. Now it can be connected to the internet, but that's not its primary purpose. Okay. It is an internet. It provides a high-speed IP-based network with connections to multiple other networks. And when you combine it with a supernode, you can consider it to be a full-scale internet. Okay. Dan.
People's understanding of intranet and internet they vary. And so most times when I talk to somebody who is discussing their AREDN infrastructure, it's always referred to as the intranet because it's not connecting to the internet, right? And so
It's not connecting to the internet, right?
there's always miss, we always conflate the internet with.
And people will
ours
do
is
that. People,
internet.
it has become commonplace to do this. Just like we have Kleenex, doesn't matter what brand it is, it's Kleenex. We have Xerox, doesn't matter what brand your copier is. Oh, it's a Ricoh copier. Then it's not making a Xerox, it's making a Ricoh, right? So, but yeah,
So the, to avoid issues, I always refer to it as the intranet, because if you don't understand that, which 90% of the people, even network engineers, they don't understand, well,
the young ones don't.
yeah, yeah. And so make sure that people understand the terms that are being
Yeah.
used.
So that's kind of what this slide is all about, is making sure people get the difference between an internet and the internet. Okay, so let's take a look at what AREDN can actually give us, if this will advance to the next slide. So here's an example of three separate AREDN networks, and they're connected to supernodes, and these supernodes are interconnected with each other. Okay, so if I am in, let me see if I can turn on my pointer somehow. Pointer options. It says automatic. I wonder if that means it's actually going to work. Nope, it's not. Let's see. Laser pointer. That's what I want. Okay. See my little red dot? So let's say I'm at this node here. Normally, I would be able to access the nodes that are my direct neighbors. I would be able to access other nodes on my mesh network just fine. No problem. But because of the internet capability of AREDN, I can not limited to just these nodes. I can access any of these nodes in any of these locations by going up through the supernet and across and down into another local network. Okay. So it's kind of a hard concept to understand. Now, if I'm looking at my local AirDen network, I'm not going to see all of these guys. I have to actually go look for them. And I have to connect to one of the supernodes who knows about these other islands, right? But I can reach them if I know that it exists by name. I can reach it from my machine right here. So that's a useful piece of information when you start talking about some of these different services and applications that we're going to run on the network. Okay. So wanted to get that out of the way first, but let's move on to, let me turn this off. Maybe. Yeah. So we've got our network. What are we going to run on it? What things can we run on it? So AirDen can host any kind of service that you can run on an IP network. So IP is the Internet Protocol. It's a protocol that was developed back in the 60s for the ARPANET, and it was designed to be a robust, fault-tolerant networking protocol. And there are multiple protocols on top of it. We've gone all through this before in earlier classes. So if you're confused by what IP is and how it works, take a look back at some of our earlier classes in this AirDen series, and you'll get some more information about it. But there are any number of different services that can be run on this network. So pretty much anything that you could run on the internet, you can run on your AirDen network. And if I'm running the service here on our AirDen network, anybody on the entire SuperNet connected network can access that service. Okay. So there's all kinds of different tools. We're going to talk about some specific tools. The services, they fit into different categories. And so we kind of broke them down into these, what do we got? 5 different categories. So communications tools, we got information storage and retrieval. We've got network management, emergency services and tactical information, and then other. Other is our favorite catch-all box. So we're going to talk about some different things that fit into these different categories and how they would work in an AirDen network. Okay. So communications tools. So let's talk about communications tools. So the one that most people think of immediately when they start playing with AirDen is Mesh Chat. And that's because it is pretty easy to install it directly on your node. So you don't need any other servers or anything to run it. It's a completely peer-to-peer system. And it will communicate and share information across your local mesh. It will not go into the supernode network and go out to the full network. Okay. Even if you've chosen the same uh, tag or network name as somebody else, it won't follow that supernet link automatically. And that's probably a good thing because this is something that's to be used mostly by the people who are building, maintaining, and managing the network infrastructure itself. Okay. It's basically a text chat, um, runs directly on the nodes. It's mesh aware. It's really easy to set it up. You basically click the menu and boom, you're rolling, right? You're ready to go. And it will connect out. And if you've chosen the same tag as the other nodes that are on the network, they'll automatically give you all the information that's in that channel automatically. And it'll just start populating and you'll see all the information. So it's really easy to join it. It's really easy to contribute to it and get information in and out of it. Um, it's not really comfortable for non-technical people to use. A lot of these tools are not real comfortable for non-technical people to use.
Yeah.
Yes.
I think why most people are familiar with that because of the word chat. And they liken that to text messaging,
Yes.
but it's really.
It's more of kind of a bulletin board, right? You post messages to it and anybody can see them. Now, that's an advantage because I don't have to be looking at my node to see the message. I can come back tomorrow and look at my node and there's the message, so I'll see it, but it's not necessarily meant for interactive conversations, right? Um, a lot of these tools will fit that category. Now, how many people have used IRC before? So IRC is Internet Relay Chat. And this was a system that was designed by some dude in Finland. Gosh, 88-ish, 88, 89, somewhere around there. Um, it has multiple servers. The servers communicate with each other. And then you have clients that connect to the servers. And so you would run a server close to you, and then you would connect your client program to that server. And you could, one of the cool things about it is it supports both direct messages and channels or groups where you could join a particular channel and start typing and other people would immediately see what you're putting in there. I used to use it heavily at work. I've used it at several different employers. Most recently was probably about 10 years ago at LinkedIn. LinkedIn used IRC a lot internally for internal communications. One of the problems with IRC is if your client's not connected, you're not going to see the messages. When you connect up to it, if you didn't have your client connected, you didn't get the messages. So you've got to be connected to see the traffic. Now, there are solutions for that. There's proxies and gateways and things that you can run that will stay connected all the time. And then you can connect to that and it will send you the data that you missed or whatever. But it can be pretty complicated. I don't necessarily recommend that we try to run an IRC service on our network. Okay. It's as much as I love IRC and I still use IRC today, I use it for keeping in touch with certain people. Um, you know who you are, but yeah, it's definitely not for the faint of heart. Um, but it is pretty cool and it does work and it does work well and it's pretty low intensity as far as like bandwidth used. Um, Jabber and XMPP. So when Java was really hot, somebody came up with this communications protocol called XMPP. It's I can't remember what it stands for, but the MP I think is or MPP that is something like multi uh, format or something like that. Anyway, the objective was to be able to send messages and attachments like images, things like that. And so a lot of people wrote Jabber servers in Java and Jabber clients in Java, which made them cross-platform, which was great. But it's one of those things that never really worked as well as you would have hoped that it was going to work. And It it was hard to use. It was annoying. There were a lot of weird little things about it that got in your face, and I don't recommend we run XMPP and Jabber directly. There are, however, some other things that will use those protocols internally, and we may choose to run those. We'll talk about that more later. Um, Let's Chat is a system of that type. It uses XMPP on the back end, under the covers. So it supports direct messaging, it supports group messaging, it supports channels, at mentions. So like, you go on like Twitter and you say at so and so, blah, 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 and the message is highlighted for them. It supports that functionality. It supports multimedia images and file uploads. It's basically a client for a Jabber network that you could run. Mattermost is another client, doesn't work with XMPP. It has its own protocol. It does support direct messages, group messages, file sharing, message history with search. If you guys have ever used Slack at work, Mattermost is probably the closest to Slack that you're going to find. And we would run the server ourselves, and clients would connect to that over just the local network, right? Um, Matrix and Synapse are kind of like Mattermost, but they use distributed servers across the network. So where Mattermost has a single point of failure, a single master server, Matrix is going to have multiple servers, and those servers will discover each other and synchronize the data between them. So if one goes away, you haven't lost all of your history. So rather than Mattermost, I would probably look at going with something like Matrix, which uses Synapse on the back end. Otherwise, it's got the same basic functionality as Mattermost. So as we look at these kinds of tools and what we would want to deploy for normal users to access, obviously we're going to want to run Mesh Chat for our own internal purposes as network operators, but we may want to support Matrix as a tool for people who are not necessarily running the network, but are using the network. All right. Email. Email is a huge thing. Okay. How many people have an email address? Everybody's got an email address, right?
Yeah, just one.
Yeah. How many people have more than one email address? Yeah. So um, we, with the AREDN, because it's running on a regular network, on an IP network, you can run a regular mail server on a node attached to an AREDN network and point your email client at it and do everything that you can do with your regular email client that you would want to do, whether you're using Outlook or Thunderbird or there are web-based clients that you can use. You can do that. So we could run a mail server or multiple mail servers across the network, and you could send email back and forth through that mechanism with standard email tools. Because you can connect a AREDN node to the internet, the facility exists for you to be able to send email out of the network out onto the internet. That requires you to do some configuration, and there are potentially legal pitfalls there because of the nature of what comes in from the internet might not be something that you want to run over your amateur radio frequencies, but it's something that could be done. How many people have used WinLink? Anybody not know what WinLink is? WinLink is a mail system. We did a bunch of classes on it last year. Basically, it's a 3-tier system. So you've got a WinLink client that you would run, and then there's a system in the middle called an RMS. And you would normally make some kind of an RF connection to that, whether it's over packet radio or VARA or HF or something like that. You'd make a connection to that RMS, and that RMS is connected through the internet to a CMS or central management system. And so all the mail goes to the CMS. And when you connect to the RMS and say, hey, do I have any messages? The RMS asks the CMS, does he have any messages? And it grabs them and hands them to you. Okay. We can do that. with AREDN. We can put an RMS on the AREDN network. But well, WinLink supports peer-to-peer, where like I have my WinLink client, and Justin, you've got a WinLink client. I could send a message directly to you without going through the RMS and the CMS. That's called a peer-to-peer connection. And I could do that over the AirDIN network as well as over RF, right? Over VHF or UHF or whatever, or HF. But because we want to take advantage of some of the features of WinLink, we look for WinLink servers, RMS nodes that are configured as a WinLink post office. And the objective here is that this node is running an RMS, and just like I could connect to it with Packet or with VARA or with HF, I can connect to it over AirDIN. There's a thing called WinLink Wednesday. It's a thing that's been going on for quite a while now. People send a message to WinLink Wednesday and they get recorded that they made a contact, right? They only accept messages that came in through an RMS because they want you to be doing it over RF. They don't want you doing it with just a direct connection to the CMS with an internet connection. The goal is figure out how to make it work with RF, right? They will happily accept AirDIN supported messages because it's going through an RMS and getting to where it needs to go. Then there's also what they call hybrid RMS systems. Hybrid RMS systems, if their internet connection to the CMS is down, they will actually use HF to connect to another RMS that can connect to the CMS. So they will find a way to get your message delivered to the CMS if you send it through that. So a lot of information about WinLink online. Check out winlink.org if you want more information. But the basic outcome is we can run an RMS on the AirDIN network and send messages through that. I've been doing that with WinLink Wednesday for the last month or so, using an RMS in, I think it's in Oregon, that I'm accessing through the SuperNet, through Sam's node on the SuperNet. Did you ever get that? Did you see my email about that? About the SuperNode not being connected?
Yeah, I was trying to get a camera working.
Ah, so you broke it. Okay.
Yeah, maybe 4 or 5.
Okay. Because I saw it showing 100% failure, and I'm like, that's not good. So, yeah, okay. Yeah, so I wasn't able to submit my WinLink Wednesday yesterday because your node was down. So, but anyway,
Yeah, you have to go back to the old fashioned.
I have to go back to Packet, right? Yeah. So, oh well, But yeah, so we can do that. We can run a WinLink RMS on our network, and we should definitely do this. Crossroads runs an RMS. James, I think, is running it. I would love to have him be on our local AirDIN network, and then we could access his RMS through that. It would be perfect. Um, we should, right now, there are no hybrid RMSs in Utah. There used to be one in Farmington, but it's offline. And
Fred is looking at setting up a hybrid
okay,
with this.
okay. Does he have AirDIN?
I don't know that he has Aaron. But
Well, we should encourage him to get AirDIN if he's going to do that, because that would be an ideal service to have on the AirDIN network. Not have to go through a supernode to get to it, right? So yeah, there's options available for email. One of the great things about WinLink is it natively supports ICS forms and other forms. So you can write your own forms for it, and it will actually present the form to you just like it was on paper. You fill it in, and then it doesn't send the entire, like a picture of the form. It only sends the data. And then the recipient has a copy of the form template, and the data gets plugged into it and shown to them with all the data. So it's pretty cool. If you've never played with WinLink, you definitely should check it out. And we do have some classes in the can on WinLink. Just check on the website. Search Murray Arc for WinLink, and you'll find a bunch of stuff. Okay. let's talk about voice over IP and audiovisual conferencing. Okay. So there's a few different options here. And these are things that are a pretty um, game-changing move for non-hams. When we talked to IHC about, well, we could put a node on your roof and then we could put a phone in the emergency department and anybody on the network could call that phone. Their jaws drop open because what if the internet's down? It doesn't matter. It doesn't care. And we would want our stuff net air gapped from the real internet anyway for that purpose, right? We would not want it depending on the internet. Um, but you can have a VoIP phone and you can direct dial from one phone to another phone. We've done this before. We've proven that this works, right? And so from anywhere on the AREDN network to any other phone on the AREDN network, I can make a VoIP phone call if I know the IP address of the node of the phone that I'm calling. That's pretty awesome.
Just make sure that he's got access.
Don't use IPv6. AREDN does not support IPv6. AREDN only supports IPv4. And in fact, the way AREDN works, everything is on net 10. So it looks like one giant flat network, which can be kind of confusing, but that's the way it works. So you can use a physical phone, and I've still got a box of some Yealink T22s and stuff like that that I'm happy to give away if anybody wants one or two. I'm happy to give those out. I paid $5 for like 3 boxes of phones, so I don't I I'm fine giving them away. I don't need any money for it, right? You can also run a soft phone on your cell phone or your PC or your tablet or whatever. There's one called Lin Phone that is supposed to work pretty well. I have not played with that very much, so I don't know how that works yet. I haven't done any experimentation with that, but it's cross-platform, runs on iPhone, it runs on Android, it runs on uh, Mac OS, Linux, and Windows. So, you can run that directly on your PC. You don't have to have a physical phone. Physical phone is neat because you can point to it and touch it, and it's got buttons on it, and we love that kind of stuff, right? But sometimes if you're in a deployed situation, it's one more 3 pound thing that you don't want to necessarily drag with you, right? So keep that in mind. You can also run a PBX system on the AREDN network. PBX, anybody know what PBX stands for? Private Branch Exchange. Okay. So if you've ever worked at a company where you had your own phone system in the company and you could like dial somebody's extension and talk to them without having to get an outside line, and you could dial 9 to get an outside line or something like that, that phone was connected to a PBX system, which is a machine that basically acts like a phone system. And it has extensions that are connected to it, and it has trunk lines that are connected to other phone systems or PBXs or networks or things like that. We could run a PBX on the network. There's a few different ones out there. There's Asterisk, there's Free PBX, which uses asterisks under the covers, and there's Free Switch, which I haven't spent any time looking at yet, but it's a new one that I just heard about today. So I stuck it on the slide. But the idea is that you register your VoIP phone with the PBX, and then it gives you a phone number. And so instead of calling you by IP address and having to know your IP address, I just have to know that Jeff is extension 357. So I pick up my phone, I dial 357, and his phone rings, just like a regular phone. If he doesn't answer, the PBX can give me voicemail. And then when he gets home and he sees the little light flashing on his phone that says he's got voicemail, he can pick up his phone and listen to the voicemail. You can do that with a PBX. You can't do that with direct phone to phone calls. Um, it's a cool thing. It is there are some solutions that I've seen for making that highly available in the event that one server goes away, another server picks it up. That's a little harder to do with PBXs because of the way they work. So we'd have to do some experimentation if we wanted that. But if we wanted to run a single one at a central location on our AirDen network, we could definitely do that. And we could set up links to other PBXs out on the SuperNet. Okay. So you could potentially say, like, I'm going to call somebody in California. I'm going to pick up my phone. I'm going to dial 8 for a trunk connection. I'm going to dial 27 for California, and then I'm going to dial his extension, and it'll ring his phone, right? Just like you would call a number outside of your company, right? Pretty cool. And then, of course, there's voice and video systems, voice and video conferencing systems. The most common ones are Team Talk or Mumble. Both of these do the same kind of thing. They are comprehensive messaging suites. They have video, they have audio, they have group messaging, they have document sharing, all that kind of stuff built into them. So we could run something like that. We would run a server, and the clients would connect to that server. Okay.
I'm assuming a lot of this takes up a lot of bandwidth.
Remember, we're talking about the high-speed multimedia network that is provided by this, and think about a phone call is going to take about 8K, 8 kilobits per second of bandwidth. We've got on a 10 megahertz wide connection, what do we get? We get about 50 megabits or something like that. So yeah, 50 is about right? So you you can run a bunch of phone calls through that connection and not really notice it.
Weekly
Voice conference.
that they run a team talk over.
Mm.
And
Who's running Team Talk?
I was looking at it today, trying to.
I've been working with it for a while. Matter of fact, I spent 6 hours yesterday trying to get the configurations right. And it goes, hey, now start your server. And it doesn't give any directions. Where do I go to start the server that I've installed and set up? I'm going nuts.
There is a serious learning curve for some of this stuff, right? And that's why us, as the guys who are building the network, need to be thinking about these services. Because I'm sorry, but let me pick on Steve just for example. Steve is not going to know beans about what PBX is, but if I hand him a phone and a node and set it up at his house, he's an amateur radio operator and he can pick up that phone and dial a number.
Steve doesn't,
Yeah.
that's his job, PBX is.
Oh, is it really? Well, maybe he was a bad choice. Maybe he was a bad choice then, but how about Adele?
There you go.
Let's say Adele, right? So, but yeah, I mean, it's like our job is to figure out how to make this stuff work and get it running on the network so that there are some applications out there and we can take this to different clubs and different groups and say, look what we're building, look what we've got, look what you can do with it. You should join us and engender the support in that fashion, right?
Doesn't Matrix do voice video too?
Matrix will do voice and video as well, yeah.
Yeah, and the reason I'm digging into the team talk, I got myself incredibly bullet camera the other day, she beat my head this long trying to get it communicated on AREDN, I hope to be able to team talk. I might have to rely on team talk to do it.
It should support.
I can't get a direct link to video. Just haven't been able to figure it out yet what the new.
It should support RTSP. You should be able to get to it with RTSP. That's the question.
To get it, because I need the password and when I connect, when it connects to my firewall at home, it changed the password and it doesn't tell me what it is.
Right.
So I can't.
Yeah. So you got to reset it again.
The team talk has the ability to share a window or an application, and so I'm thinking that might be how if I can't.
So you get somebody on the line with you on Team Talk, share your screen with them, and then you work on it together. Yeah.
Bring Sunday at noon when the express riders come through, and I'd love to have a camera.
That would be cool.
Once in.
That would be really cool. Yeah,
That's that.
that would be cool. I'd like to see that. All right. Information storage and retrieval systems. This is things like file sharing, video streaming, web servers, that kind of stuff, right? So file sharing, you've got your basic FTP. FTP used to be like the tool people used for file sharing back 20, 30 years ago, right? In fact, there were tools out there. There was a tool called Archie that would help you figure out what FTP server had the thing on it that you wanted. So you would go into Archie and search for something, and it would come back with a list of FTP servers that had that. It was like an index for FTP servers. This was pre World Wide Web stuff, right? Um, FTP is kind of a weird protocol because it's old. It does things in a very strange fashion. It sends things in both directions. It's doing all kinds of crazy stuff, but it works fine on the mesh once you have your server set up correctly. And it does support anonymous access, so you don't have to worry about passwords or anything like that. So you can set that up fairly easily. There's also, we could do NFS or SMB remote disk access. So I can share a drive on my server as either an NFS drive or an SMB. SMB is a server message block. It's the Windows file sharing mechanism. NFS is network file services. And that was the system that was developed by Sun Microsystems that was used for Unix systems back in the day. It was heavily used back a long time ago, not so much anymore. But there are these types of systems that we could deploy and turn on, and people could access that with their regular computer client. So you could have functionality like a Dropbox folder where I can drop a file in there and it will copy it over the network to that server, and then anybody else can grab it from there, right? So that's functionality that you could get from this. I could also maintain an archive of things. Yeah, go ahead.
Run this at the nowadays.
You can. Yes. Yeah, if you're running Samba. I don't know if you can turn it off in Windows. There's probably a knob to turn it off somewhere in Windows, but it's buried in the registry somewhere, and I have no idea where it would be. But I know you can do it with Samba. So yeah, we can do this network file sharing thing, and I'll have a large disk shared to multiple people. And again, we can mirror that disk on multiple servers. So if the one node happens to go down and we lose that one, could be other ones that are synchronized with it. There are also some groupware type tools. What's the one I'm thinking of? Next something. Nextcloud that we could use. We could leverage that. Nextcloud has an email server, it has chat server, it has file sharing services. It's got, automatic picture uploads from your phone to it. There's a lot of things that it can do that we could turn on if we wanted to do that. And it supports mirroring out to other servers for redundancy. So some cool functionality that we could make work there. Video streaming, IP cameras, right? I keep telling Murray City, I want to put a camera on top of the tower that is remote controllable, that I can turn around and look in different directions and see what's going on. And they're like, you're going to look in someone's window and we're going to get sued. And I'm like, it doesn't have the resolution to see that. It's not like a telescope. It's like a webcam sitting up there, right? It's already 300 feet in the air. It can't see. Yeah.
Just one pixel.
Yeah, it's not gonna see anything, right? But the lawyers are like, blah, 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 lawyers. So we're working on that. But I think that would be awesome to be able to say to the fire department, hey, you can look around the valley and see visually that bridge is down That bridge is not. Let's go check that out and make sure it's structurally sound enough to drive a truck under. And then if it is, we know we can get through there. We don't even have to go to the one that's completely a pile of rubble because we know that one's no good, rather than having to look at every single bridge, right? We could do that remotely from the network camera. There's also tools that you can attach these cameras to, like iSpy, Motion Eye, ZoneMinder, that will take feeds from multiple cameras and present them in a nice little display. So like a little grid of camera views. And they can be configured to only record if something changes. So for example, we could put a camera in the radio room at the tower and just let it sit there and take pictures all day long and not bother to record it unless somebody walks in there. And then as soon as somebody walks in, we record everything that they do while they're in there. And that way, if something happens to our equipment or somebody else's equipment in there, we have a record of that. So there are things you can do with these tools that allow you to do that kind of thing.
We don't need that though, because we do have extra security. Yeah.
Yeah, we do.
The cold wasps.
Yeah.
Dan, it's no loss.
I give the entire security bulletin.
Oh, man.
Why did I know that was coming?
Now, I also heard about this one called Shinobi. I don't really know anything about it, but for completeness, I put it on the slide. So I have no idea what it is or what it does, but it's another one of these kind of video tools.
It's part of our documentation.
Yeah. I saw it on there, and that's why I included it here.
The key things I saw on that is that Motion Eye and Shinobi are on Raspberry Pi.
Oh, okay. So personally, I don't think a Raspberry Pi is a great computer for running big services on, just because it's not much of a computer. And you can get a heck of a lot better computer for not a lot more money. So there are other options, but Raspberry Pis are great if that's what you've got. And they're pretty cheap to get started with and play around with. And they do have some cool functionality for hobbyists with the exposure of the GPIO pins and things like that. You can do some cool stuff with it. So I'm not saying it's a terrible product. I'm just saying it's not great for running a production service. So I've got a couple of Raspberry Pis at home that I use all the time. So also web servers, any website could be mirrored onto the mesh. Imagine if you had a full copy of Wikipedia at your disposal if you needed something that was on there. Or there's any number of sites that have records, information, data that would be useful to have access to in an emergency when the internet is down. We could mirror that up front, put it on a file server, stick it on the network. Anybody on the network can access it. So to me, that's a killer app right there, being able to do that.
Probably one of the best uses of web servers on the network is local clubs posting their information.
Yeah, we could mirror our club website onto the mesh.
Yeah,
and it would be there. Everything that's there would be there. Yeah. Everything that you would want can be available without the internet, right? We can also install a web proxy to facilitate access to live sites on the internet, the internet. There are, again, corresponding gotchas with that, legal reasons why we may want to restrict access to that. We can do that. There are facilities to do that, right? So we can control, you have to have a username and password to get through this proxy to access things out on the internet. We can say only hams who've had the training get access to that, right? Or something like that. So there are options. So network management. This is one. Thanks for coming, Dave. Have a good night. Network management is kind of a thing that would be used more by the people who are building the network, not the users of the network. But sometimes having that information visible can be very helpful to people when they wonder, well, why can't I reach system X? Well, it's because gateway Y that's in between you and system X is down. And since it's down, you can't get to system X, right? So that kind of thing can be useful. But there's the AREDN nodes already have a facility to supply metrics in a format that Prometheus will scrape. So all we have to do is run a Prometheus instance on a machine somewhere and pull that data from as many nodes as we want to pull from. There's already a URL endpoint for the node to get that data. And you can take that data and then Grafana will graph it for you in a nice to look at graph. This is what we call time domain data. So it's data that rotates as time goes on, right? So you would see like a moving graph, a refreshing moving graph that would show you what's happening. There's a tool called Mesh Map that will go out and survey the mesh, all the nodes on the mesh, and produce a map showing where the nodes are and what the interconnections are. If you've ever gone on your node and there's that little map down in the corner and you click on that, that's Mesh Map. And you can see all these links that nodes are connected out there. It only works by default if you're on the supernode network, but we could run our own mesh map internally to our network. So if the supernode was down, if Sam breaks the supernode again, and the supernode is down, then we could have the local map and show us where our links are. And right now we've got a lot of internet links between nodes. I want us to get more RF links between nodes, right? That's kind of the goal, is to have this on RF, not be dependent on the internet for these tunnels. So when we get to that point, it will make more sense to have some of these services on our local network. Because what if the supernode is down? What if the internet is offline? Maybe we'll be able to gateway through Starlink and be okay. Maybe not. We don't know, right? It depends on how swamped Starlink gets in that case. We may find that our bandwidth through Starlink is unacceptably slow. If we've got a physical network that doesn't depend on the internet, that's much better for us. But there's a bunch of different tools, Nagios, Cacti, Smoke Ping is one that I've used before that gives you a nice diagram that shows the ping time between nodes. And you can see visually how good your connectivity is to different places. You have to configure that, set it up and run it, and it periodically queries stuff and pulls this information in and displays it. But it's kind of cool stuff. It's more tools for us as the network managers to use to make sure that the network is working correctly, right? Nagios will do things like monitor services and make sure that if a service isn't running, somebody gets notified about it. So if, for example, I've got a file server and the disk is getting full, Nagios can tell that and warn me before it fills up. Hey, you might want to get more disk or clean this up a little bit and have more room for future stuff or things like that. There's also testing and debugging tools like traceroute and ping that are actually built into the AREDN software, and you can run. It's pretty cool, actually. You can say between any two nodes on the network, you can run a traceroute between them or a ping between them and see the information dynamically in real time. So it's pretty slick. Even if you can't log in on the node, you can still have it run a traceroute from that node. So it's kind of fun. All right. Emergency services and tactical information. This is probably the most fun kind of stuff that we can talk about. Computer-aided dispatch. There's a tool called the MCOM map that basically allows you to track the positions of emergency resources. Like, where are my fire trucks? Where are my staff members? Where's the mayor right now? That kind of stuff. You can track that on this map. It has a nice interface where you can show it to somebody like Nick and say, look, here's the information. Even though you have no idea how it got on that screen, there it is, right? And that's okay that he doesn't know how it got on that screen. He doesn't need to know that as the emergency coordinator. He needs to know where things are. right? And that's what we can provide with a tool like that.
City GIS people using that.
I don't know if they're using that or if they're using their own internal tools, or there's probably some commercial tool that they're using. But this does the same kind of thing as those tools. So they would be familiar with how the tool works, not necessarily the specific tool. Okay. So we may have to coach and be available to help people understand that. We need to understand it first, obviously. We need to play with it ourselves first so that we know how it works so that we can help other people understand it.
So that's like open source.
It's open source, yeah. There's this open ISES. ISES stands for Information Systems for Emergency Services, and it supports the tickets system, which the emergency services people should be familiar with already. This system is available. We could install a server for that and run it on our network, and they could run their tickets through that system. So if their system was down for some reason, which we half expect the public service radio network to be down because it's using fiber backbone links, and it's also going to be seriously swamped with everybody that's trying to use it. So being able to leverage a completely separate network and provide them with an interface that they're comfortable with could be a major win. There's GIS and map pile servers that we could run on the network. So we could have a single place with map information and distribute that dynamically. So that mesh map can pull those map tiles from a map server. It doesn't have to be a map server out on the internet. It can be one on the mesh. We can run that locally on the network. TAC is one that I've played with a little bit. It's a government tool. TAC stands for Team Awareness Kit. And if you check out tac.gov, you'll find out a lot of information that you probably didn't want to know. But it's really pretty slick. There's a client application for Android, at least, called ATAC, and it will present you with a little map display with your other team members on it. And you can update your position automatically, and it will transmit that information back and forth. Well, obviously, it needs a working network to be able to do that. We can run that service on the AREDN network, or you could run it on Meshtastic, which is another cool thing. We'll talk a little bit about Meshtastic in a sec. As far as tactical information, we could run an APRS gateway and distribute APRS data across the mesh network. So if we've got multiple APRS iGates that are connected to our network, our AREDN network, then they could work independently of iGates that are trying to connect to the internet. The internet may not be available, but our network ideally will be available, right? So we can do APRS through that. You can even pull ADSB and AIS data. AIS data is not real interesting for us. AIS data is like ADSB for ships. Okay. We don't really have a lot of ships around here.
California sinks in.
Right? Yeah, then maybe, but ADSB with aircraft information, you can put an ADSB receiver out there and have it present that information on the network, and then anybody can see that information. So you could overlay that on your map and be able to see where airplanes are at any given moment. And you could limit that to specifically where are my life flight helicopters and my Utah Highway Patrol helicopters at right now, and not worry about general aviation or anything like that. Or if you've got an integration with Civil Air Patrol, maybe you want their planes to show up on there. You could set that so that you only display the ones that you want to see. So we could easily map that into a mapping system. WeWex is a weather service. It used to be really popular for people to run their own weather stations and connect them to APRS. Some people still do that. A lot of people are now using Weather Underground, or they're using whatever their weather station came with as far as the network service to upload their data. If their tools are compatible, you can present that through WeWix directly on the network. It acts like a web server, and so you can pull that information. We could pull that and summarize it, put it on the map, whatever we wanted to do with it. Even plug it into APRS directly from whatever they're presenting it with. And then network time services. We did a class on network time on NTP and the ilk there. So if you're not familiar with NTP, take a look on the MARC website for NTP and you'll find a class on that. I talked about time in general and how we track it and why we track it and why we care and that kind of stuff. So, but you could run a clock server on the mesh and then anybody could access that and pull accurate time down from that. Accurate time becomes really important for certain protocols. So that can be a very valuable thing to have. Last thing for emergency service and tactical information is health and welfare reporting. So one thing that we could do is utilize standard forms like the radiogram form. We could have a stack of radiograms at a location, fire station or school or something like that. People could fill it out and hand it to an amateur radio operator, and they can shoot it out with WinLink rather than having to get on a VHF connection or an HF connection and try to pass a message that way. Much faster to shove it through a WinLink connection than trying to do it by voice over HF, right? There's a thing called HAMHA. I don't know a lot about it, but it's supposedly designed to handle health and welfare reporting for different disasters and events. They use it for things like hurricanes and stuff like that. We could certainly use it in the event of a earthquake or something around here. So Bob Segrist is a guy that he developed a system called EHA that basically you set up a machine and it presents an open Wi-Fi access point and anybody can connect to it. And when they do, they get a web form where they can put in their name, an email address to send it to, and a brief text message that says, I'm okay or whatever, right? And then it turns that into a WinLink message, but it allows the operator, the amateur radio operator, to review it before it actually gets sent. Bob does not have that publicly available right now because there wasn't any real interest in it, and so he pulled it. I've been talking to him, trying to convince him to at least put the software back out there on GitHub, but if not, we could always roll our own and do something similar to that. It would not be hard with the software development power that we have in the club right now. We could easily build something pretty quickly and distribute it. That would do that kind of a thing. So a lot of things we can do. Some things are what we call SMOPs, simple matter of programming. So, we may have to do a little coding to make things work the way we want it to, but these are all possibilities. And then,
You during this class on what?
yeah, right? Yeah, about vibe coding. Yeah, no. Other things. Anything you can think of that will run on the network can run on an AREDN mesh network. Repeater linking. Paul has been talking about doing this with his 10-meter repeater that he wants to build because he doesn't want to build a cavity filter for 10 meters. I don't know why. It would only be,
Refrigerating.
it would only be extremely large. But so he wants to set up his repeater with multiple receivers that are geographically distant from the transmitter and have them do some kind of voting to decide which receiver's signal actually gets sent through the transmitter, right? If you're putting these things, a mile away, an AREDN link could cover a mile distance with no trouble at all. I mean, you don't even need much of an antenna for that. So he's been thinking about, I could do this. I could use a VoIP link over an AREDN network between my receive site and my transmit site, and I can do telemetry and whatever else I want to do over that link too, because I've got plenty of data space, plenty of bandwidth on that to do what I want to do, right? So repeater linking could be done through this. Telemetry receiving. Imagine if we have flooding with the creeks and rivers every year. You could easily put a sensor that measured how deep the water was and just had a little server on it that would present that information. Some tool like Prometheus could come by and scrape it, pick it off, and you'd get a nice graph showing the water level as it changes throughout the day, the weeks, the summer and winter and whatever. Easy to do that with AREDN. Super easy to do that with AREDN. It would be kind of cool to build that and do that. You could do that with APRS as well, but we're building AREDN here. We're not building an APRS network. We're building an AREDN network. An information archive. We talked about that in regards with the file storage. A copy of Wikipedia. Imagine if you had that with you when the internet was down and you needed to look something up. Maybe Wikipedia is not a great choice, but maybe there's another reference material like how to recognize different rashes and what they mean or something like that. Something like that could be available. Yeah.
I actually have a backup of a few other resources like that in my emergency breath. It's on
a thumb drive, right?
On multiple large thumb drives.
Yeah.
But there's a program that you can use to
mirror that.
do everything
Yeah.
local. So
Yeah.
internet not required.
Yep.
And I have all the information as of 2024.
This could be up to date up until the moment the internet went away, right? Software archive, similar kind of thing. I don't have WinLink. Well, I can get it from a software archive and install it, and I'm ready to go. Now I have it, right? Information about how to configure that could be on there as well. Shared logging and reporting. Some group was doing a field day, and they were using an AREDN network at their field day site. I can't remember who it was. Was it UVARC doing that?
UVARC.
I think it was UVARC, yeah. They were doing that where they were using some kind of centralized logging software, but they were using AREDN to supply the network from all of the different sites that were doing field day that day. They were all connecting in and using the same central logging server. Easy to do with AREDN. Remote-based radio operation or repeater management. I know we've got a list of DTMF codes for our repeater, but imagine how much easier it would be if you could telnet to the repeater and access the menu system directly on the repeater. That would make things a lot easier to maintain and update and check telemetry and that kind of stuff. The UARC runs the remote base down at Levan. If that site was on an AREDN network, you could access it even if the internet was down. Could be cool. And then Meshtastic, your Meshtastic nodes are happy to connect to a Wi-Fi network as well and use that as a backbone for high-speed connections between Meshtastic nodes. I don't know what all we can do with Meshtastic. I have a Meshtastic node. I haven't really done much with it, but I know that TAC works with Meshtastic. And so if we had some central Meshtastic repeater nodes that were on the AREDN network, all that data is immediately available on the AREDN network. Lots of things you can do with that capability. Not just Meshtastic, but other protocols as well, other networks and things you could tie into. People with Starlink can hook into that and have actual internet access and present, make that available in some kind of filtered fashion to general users on the AREDN network. Again, you've got to be careful with who you give access to and what kind of level of access you give, But those are all things that we would want to figure out as we're doing this, right? As we're building this out. That's all I got as far as the presentation goes. And it looks like it's almost 8, so I think we did pretty good. Any comments or thoughts? Yes.
I didn't see any list there, Chat GPT or DeepSeek or any of the AI stuff. When are you gonna?
I'm probably not. There are some LLMs that you can run yourself locally that you can give them, you can seed them with some information that you have. So imagine if you took one of those and you gave it all of the amateur radio tests and answers, questions and answers. And then you could ask it questions about things that are on the test. And it would tell you the things that you wanted it to tell you, There are facilities to do that. That technology is too young right now to depend on, but there's a lot of things that it could do that could be really cool. I don't know. We'll have to see what happens. But personally, questions that I've asked ChatGPT, it has given me the wrong answer more often than the right answer. And fortunately, I know enough to be able to tell the difference. But it's only as smart as the data you've seeded it with. It's not. Yeah, it's early stages. And
you've got to ask it something different than should I buy new socks? Or, give it something challenging, okay?
now the question is, how many new socks should I buy if I never want to wash socks ever again? Right? Somebody did that as an experiment. They actually did the math on that, and they figured out how many pairs of socks they needed to buy in order to have a clean pair of socks every day for the rest of their life, and never reuse a pair of socks. Just either toss them or whatever, but you never wash them. Never, because how many times have you washed a pair of socks and gotten one sock back, right? Where's that other sock? Is it on some other planet somewhere? Did it go through a hyperspace dimensional duct, and get somewhere? Did it turn into a hanger or a paperclip? I mean, I don't know what happened to it.
That's the hospital level form. Okay.
Yeah, right?
Something like your sock question. All right, this is real. North Carolina. I was requesting a death certificate. So I'm on their site, I'm going through their menu selection. And so I'm already looking under categories of death certificate. So it goes, death certificate. You want one for somebody else or your own?
Yeah. Yeah, I want my own. I want my own, please. Yeah. Yeah. I'd like to know when it's going to be so I can plan. Yeah. No, that's a problem, right? I mean, that just goes to show you that it's not just AI that's dumb. It's regular eye that's dumb as well. So, yeah. So
This is
anyway.
Brainiacs who put, Braille on the drive-through.
Right,
ATM.
right, yeah.
He says, what are you doing?
That only works if they walk up to their.
All right. If there are no other comments about AREDN applications, I'm going to stop the recording and I will get this online as soon as I can. I have last week's that I need to get online still. Were you going to send me the slides for that?
I didn't.
I don't recall seeing them. Anyway, I'm going to stop the recording and we will see you guys next time. Thanks.